Good afternoon. So when we sell something, usually we kind of expect to get something out of it. We get a price. For example, if you sell an item on eBay, or for example, you get something out of it. That's an assumption we typically make, but for energy, that's not always the case. Actually, when we're talking about renewable energy production, sometimes when there's too much renewable energy being produced and not enough demand, prices can actually go negative. And this is not a rare case anymore. In Belgium, in 2025, we've had more than 407 hours of negative electricity prices by August of this year. During these hours, producers of electricity that wanted to sell their electricity were actually forced to pay themselves to put the electricity on the grid. This clearly indicates that our current grid infrastructure is currently being outpaced by the growth of renewable energy production, such as solar panels or wind production. So we need a solution. One possible solution is what we call energy communities. Energy communities is just a group of buildings being connected together. These buildings could be houses, they could be schools, they could be offices. They're connected together. They produce and manage energy that they produce within the neighborhood locally first, before putting it on the grid. It's kind of a win-win situation in a sense, because we have typically different profiles. Think, for example, of an office building. It has solar panels. Those solar panels produce energy 7 days out of 7, but during the weekend, there's no one around. So energy is being produced, not necessarily used. In this case, what we propose is send that energy to neighboring houses, for example. It helps stable out the grid, so there's no more big fluctuations anymore, like we typically have during the day, a lot of energy, and during the evenings not. It guarantees better prices for the sellers because you don't have to pay that much grid infrastructure, and it guarantees better prices or even access to renewable energy for people that might not necessarily have it. But managing such a community is kind of complex. There's many decisions you need to take. Do I sell my energy now? Do I store it if I have a battery? If I sell it, to who do I sell it? At what price do I sell it? And to make matters even worse, these decisions have to be taken frequently. Oftentimes, every 15 minutes or every hour, you have to decide, what do I do now? So clearly, asking someone to do this manually would be very unrealistic. So the question becomes, we have these communities, but they're not really feasible. How can we make them feasible in practice? And we'll go through 3 steps of the process. First, we'll see how reinforcement learning can help automate some of these decisions. Then we'll see how we can virtually simulate these communities to be able to understand how they work and to make them more efficient. And finally, we'll look at an interactive demo that makes these concepts accessible to non-experts. This could be citizens, these could be policymakers, and so on. So first, reinforcement learning. So RL agents are kind of inspired by how we as humans learn. So through trial and error or trial and evaluate, they take an action. This could be charge your battery, this could be sell energy. They observe the outcome, what's the current price, what's the current situation in the community, and then they try to adjust their behavior over time to optimize. Typically, they optimize a long-term reward. This reward could be anything. It could be minimizing your costs at the end of the year, so your facture. It could be maximizing self-sufficiency. How much of my renewable energy am I actually using? It could even be something like maintaining a certain comfort level. I want my house to be at 20 degrees most of the time. This is one agent, obviously. What happens if we have many agents? In this case, in our energy communities, what we do is each household or each building becomes a different agent. They're all optimizing their own goal. Some of them are optimizing for cost. Some of them, like government buildings, for example, are optimizing for sustainability or for fairness. We put them together. We give them different resources because that's something you can expect in real life as well. Some of them will have solar panels. Some of them have batteries. Some of them have none of them. And we kind of simulate what happens in the process. For this, we built a high-performance simulator with a big diversity of agents. We have rule-based agents, very simple agents. They follow rules like I'm selling my energy between 9 a.m. and 5 p.m. and for the rest of the day, I'm just not doing anything, all the way to reinforcement learning inspired agents. So they learn how to act over time. We also have different types of mechanisms. I said earlier, how do you do this exchange? Well, we go from no exchange at all, so the current situation, you could say, to what if we just have like some fixed price or some adaptive price, or even what if we have a market system, so agents can decide what price and what quantity of energy they want to exchange. We use a diversity of realistic energy profiles, so energy consumption data from schools, from houses, a bit from everywhere. We put them together, and then we measure out fairness, efficiency, and sustainability or emissions by the community to try and make them more optimal. One thing we noticed is even in very simple setups, very simple rules, for example, a fixed trading rule, you can actually increase quite a bit the total cost of energy and have quite a bit of reduction in wasted renewable energy. In this case, what we mean with wasted is, when I said earlier negative prices, you kind of pay to put it on it. The grid doesn't want it, but it is forced to take it. In this case, we don't have that anymore. Obviously, the sandbox is very nice for us researchers because we can test out very quickly and on a very large scale different setups, different exchange mechanisms and whatever. But if you go to citizens or to policymakers and you give them this, it's not very accessible. And so therefore, what we did is build an interactive demo on top of it. It starts with the very basic concepts: what's electricity consumption, what's production, what affects it, and then kind of builds up all the way to let them create their own energy communities and play around with them. The nice thing about the simulation is because it runs on top of the sandbox, you can feed it any type of data you want. You can even request your own data from your energy supplier, fit it in, and see what would happen. You can add houses, add batteries, add solar panels, run different what-if scenarios. What if I buy a battery myself? What happens? And you can test it out. And the same platform can also be used by legislators to test out policies virtually before deploying them in the real world. So in conclusion, our current grid infrastructure cannot cope with the rapid growth of renewable energy production. We need new systems. Multi-agent reinforcement learning offers such a solution in this case. And through tools like our sandbox and our demo, we try to make these tools practical and accessible for citizens and policymakers to get started with. Thank you.